Hello, hi everyone. I hope everyone is doing great. Welcome to the next video of the one shot series. In this video lecture, we are going to discuss some previous year questions of periodic classification of elements. It's really a very simple topic and easy to score topic. So let's proceed in the systematic manner to discuss this topic. So first, we are going to discuss the weightage, then we are going to discuss syllabus, then mind maps, and then we will start solving the previous year questions. Okay, so let's proceed one by one. Before starting with the weightage and other things, how to use this video? First, you have to revise your short notes, you have to jot down the important information, and then you can start doing the practice with me. So let's discuss the weightage. So generally one question is going to come right from this topic, but there are so many sets in which two questions was there. Okay, so it's a very scoring topic and easy topic. And what is the most important topic in periodic classification of elements? That is the periodic properties. If I talk about the periodic properties, it means you should know the trend across a period and down the group with respect to atomic radii, ionic radii, ionization enthalpy, electron gain enthalpy, electronegativity, and the nature of the oxide. So generally the questions are going to be from this topic. Yes, we have other topics also, but these are the most important topics. Okay, so now let's discuss the mind map. So entire periodic table or periodic classification of element is divided into three things. In the first part, we are going to discuss the history, which is in the development of the periodic table. So while developing the periodic table, we have certain laws. So the first important law is the Dobereiner's law of triads. After that, we have some limitations, right? Then we have Newland's law of octaves. After that, we have Lothar-Meyer classification. We have Mendeleev's periodic table, and then we have modern periodic table, or we can say Moseley's periodic table. So Dobereiner's, Newland's, Lothar-Meyer, and Mendeleev, that is all memory based. So you should know the law, limitation and advantage, and some important properties associated with the Mendeleev's periodic law. Now, the entire periodic table, or we are going to discuss the modern periodic table, right? So the modern periodic table is divided into 18 groups, 18 vertical columns, so 18 groups, 7 horizontal periods. Then we have 4 blocks. 4 blocks are S, P, D and F block. So if the last electron enters into S subshell, then it belongs to the S block, and S block elements are group 1 and group 2. If we have the P block elements, it means last electron enters into P subshell, and we have a P block from group 13 to group 18. Then we have D block elements. D block elements are also known as transition elements, where last electron enters into D subshell, and D block is from third group to the 12th group. Then we have the last group, that is the F block, or we can say F block elements are also known as inner transition elements. They belong to group 3 and they are placed separate below the periodic table. And F block elements are further divided into lanthanides and the actinides. You should also have the idea about the diagonal relationship. One or two questions is from the diagonal relationship also, it can be asked. Then we have the nomenclature of elements, or IUPAC nomenclature of elements having atomic number greater than 100 or 100. So we have certain set of rules, so you have to follow that rule in order to do the nomenclature. Lastly, we have to discuss the periodic properties, or the questions are going to be from the periodic properties, right? That's the most important. In the periodic property, we have atomic size, atomic radius, ionic radius, ionization enthalpy, electron affinity, electron negativity, nature of oxides, nature of oxides, and entire set of periodic properties. They depend on three factors. First is the effective nuclear charge, second is the shielding constant, and third is the distance between the nucleus and the outermost shell. So if you have good grasp on these three things, effective nuclear charge, shielding effect, and the distance between the nucleus and outermost shell, then you can relate with the periodic properties, or you can do the comparison. Right, so you should do the revision of all these topics in detail before starting with the questions. I hope I am clear. Now we can start doing the question. So let's do question number 1. Match list 1 with list 2. So A is the melting point, B is the ionic radius, third is the ionization enthalpy, and the fourth is the atomic radius. So we have to match list 1 with the list 2. So let's do it. So first is melting point. A is what? It is the melting point. So what is the general trend for melting point? Melting point decreases down the group. General trend is this, the melting point decreases down the group, and that is for group 13. Group 30. So now what is the expected trend over here? What is the expected trend? So expected trend is boron melting point is greater than aluminium, then gallium, then indium, and then thallium. So how to learn the group 13? Baggets, or we can say Bagan, aloo, gajar in thela. So in that way you can learn this, right? Bagat or bagan, aloo, gajar in thela. So this, basically this is the mnemonics, right, that you can use over here. So the expected trend is this. But what is the actual trend? What is the actual trend? So this is now group 13. So in the group 13, we have metals, right? We have metalloid, and on moving down the group, what happens? Metallic character increases. Metallic character increases. So that metallic character also produces, we can say, anomaly in the actual trend, right? So what is the actual trend over here? So we have boron, then aluminium. Boron and aluminium, right? Boron melting point is more than aluminium. And after that, we have thallium, because down the group metallic character increases. So if metallic character increases, metallic bond increases, then the melting point is going to be more. So we have thallium. And after thallium, we have indium. And the last one is the gallium. So if we check the list number 2, so A can be matched with option number 4. A can be matched with option number 4. So can we see where is option number 4? A can be matched with option number 4. So we have only one option with respect to that, right? That is option A. So A is going to be the correct answer, but let's discuss the ionic radii, ionization enthalpy in that way. Okay. And now we have to discuss the ionic radius. Ionic radius, B is the part of ionic radius. Ionic radius. So what is the trend of ionic radius? Down the group. Down the group. Ionic radius. Ionic radius increases. Right? Down the group, ionic radius increases. So what is the group? Boron, aluminium, gallium, indium, thallium. So down the group ionic radius increases. So what we can say for B? B ka most size or largest size is for thallium. Then we have indium. Then we have gallium. Then we have aluminium, and then we have boron. Right? So that is going to be the trend. So B can be matched with option number B can be matched with option number first. Option number 1. Okay? So B can be matched with option number 1. Now, let's see for C. So C1, ionization enthalpy. So what is the order of ionization enthalpy? So generally ionization enthalpy decreases down the group. This is the normal trend, right? Decreases down the group. Decreases down the group. But what do we have over here? If we talk about the ionization enthalpy trend, so highest is for boron, then it is for thallium, then gallium and aluminium almost same, and then we have indium. Then we have indium. Now, how to understand this? How to understand this? So see, boron, it is 2s2, 2p1. Aluminium, aluminium is 3s2, 3p1. Gallium, 4s2, 4p1. Indium, 5s2, 5p1. And thallium, 6s2, 6p1. Now, before 6s, electrons, right? Electrons are in 5d and 4f. And indium, electrons are in 6, not 6d, that is in 4d. 3f is not possible. And in gallium, electrons are there in 3d, right? Before 4s and 4p. And now, if we talk about the shielding effect, so shielding effect is S greater than P, then D, then F. It means if the electron is in the S orbital, then it can create more shielding, in more repulsion onto the valence electron in comparison to P, D and F, right? So F has poor shielding effect, due to which effective nuclear charge onto this valence electron, right, increases in case of thallium, due to which we have to provide more energy in order to remove the electron from isolated gaseous atom, right? Up then after that we have gallium, and because in the gallium we have 3d, and in indium we have inner shell electron which is in 4d. So obviously 3d is closer to the nucleus, right? So here effective nuclear charge is more. Okay, then gallium, aluminium almost same size, or sometimes we can also write boron, thallium, gallium, then aluminium, and then indium. So this can also be true. So this is going to be the ionization enthalpy trend. Now the last is atomic radius strength. So atomic radius strength is on moving down the group, size increases. So it means we have D में सबसे ज़्यादा thallium, then we have indium. Now aluminium size is slightly greater than gallium. Slightly greater than. Aluminium size is slightly greater than. Why? Why? Because due to poor shielding effect of 3D electrons. Poor shielding effect of 3D electrons. Right. So effective nuclear charge in case of gallium increases slightly in comparison to aluminium. That's why gallium size is slightly less in comparison to aluminium. Now why it's not in indium and thallium? Because on moving down the group, electrons also increases, and due to the increase in inertial electrons, electron repulsion also increases. That's why there is no such effect onto the atomic size in that group. I hope I am clear. So if we match the option, so option is going to be A, right? Option is going to be A. Now let's do the next question. So next question is, given below are two statements. Statement 1, the oxidation state of an element in a particular compound is the charge acquired by its atom on the basis of electron gain enthalpy. Is it correct? No, it is not correct. It is false. Because oxidation state of any element in a particular compound, it completely depends on electronegativity, not electron gain enthalpy. For example, suppose we have water molecule, right? Water molecule. So first of all, oxidation state is the hypothetical concept already discussed in the redox one. So if I break this bond, so we know that oxygen is on right hand side in comparison to hydrogen. So oxygen is more electronegative and hydrogen is less electronegative. So if I dissociate this bond, then hydrogen is going to carry +1 charge because there is a one bond, right? And oxygen is going to carry -1 charge. If I dissociate this bond, so again hydrogen carries +1 charge and oxygen is going to carry -1 charge. So it is based on electronegativity, not on electron gain enthalpy. So the first statement is going to be false. It is incorrect. Now let's understand the second statement. P pi bond formation is more prevalent in second period elements over other periods. Yeah, it is true. It is true. Why it is true? So see, in second period, we can have 2s and 2p. Up now we know that P is dumbbell in shape. So P can form sigma bond, like if this kind of overlapping happens, so it can form sigma bond, head on head overlapping. P can also form pi bond like this, that is the sidewise overlapping like this. So it can form pi bond. Okay? But if we move down, or if we move down the group, then in third period in third period we can have electrons in 3s 3p and 3d भी हो सकता है ना. 3s 3p 3d. अब जैसे 3d starts to fill in fourth period, it starts to fill in fourth period, right? So in third period, if we want to form pi bond, so that is going to be 3p pi and 3p pi. Here if we have pi bond, so that is going to be 2p pi and 2p pi. And if we talk about the fourth period, so in fourth period, we can have electrons in 3d, 4s and 4p. So if we have pi bonds with respect to d, so that is going to be 3d pi and 3d pi. So generally from fourth period, we have 3d pi and 3d pi bonds in comparison to p pi bonds. So fourth period में 3d pi आ रहा है, right? So from this we can draw the conclusion कि it is more prevalent in second period, and down the group p pi bond formation tendency is going to decrease. It doesn't mean कि that is not going to happen. It means it decreases. So statement 1 is incorrect, but statement 2 is correct. So option C is going to be the correct answer. Okay. Now let's do the next question. So again, match list 1 with list 2. So, list 1 chlorine and sulfur. Second, germanium arsenic. Third, francium radium. And D, fluorine and oxygen. Properties in their respective groups. So, we have options: elements with highest electronegativity, elements with largest atomic size, elements which show properties of both metals and non-metals, and elements with highest negative electron gain enthalpy. So see, elements which show properties of both metals and non-metals, so they are metalloids. They are metalloids. So what are metalloids over here? So if we see option number B, germanium and arsenic, these are metalloids na. That's where they have the properties of both metals and non-metals. So B can be marked, or B can be matched with option number 3, third. Right? Then we have fluorine and oxygen. By highest, fluorine is the most electronegative element. After fluorine, we have oxygen, and then we have nitrogen. So these are the 3 most electronegative elements. So fluorine and oxygen, we can match with option number 1. Then we have francium and radium. So francium and radium, so see, francium belongs to group 1 and radium belongs to group 2. Radium belongs to group 2. How? See, Helen, Lennon, na, karo, road, cross, frequently. Then beta, mange, car, centro, bar, razi. So francium and radium, right? So this belongs to first group and this belongs to second group. So we know that down the group, size increases. On moving down the group, size increases. And on moving left to right, size decreases. Yes, on moving left to right, size decreases. Okay, so it means francium and radium with largest size. So francium and radium can be matched with option number 2. So C can be matched with option number 2. Now we have A, chlorine and sulfur. So chlorine and sulfur, elements with highest negative electron gain enthalpy. Yes, so A can be matched with 4. So if we talk about electron gain enthalpy, right? Electron gain enthalpy. So see, we have fluorine and chlorine, and then we have oxygen and sulfur. So third period elements, they have more electron gain enthalpy in comparison to the second period elements. It means chlorine electron gain enthalpy is greater than 4 and sulfur electron gain enthalpy is greater than oxygen. Why? Because oxygen and fluorine, they are small sized elements. Small sized element means fluorine 2s2 2p5 and oxygen 2s2 2p4. Sulfur is 3s2 3p4 and 3d is empty, and chlorine is 3s2 3p5 and 3d is empty. So chlorine needs to add one electron, but the space in chlorine is more, so it is easier to add electron in case of chlorine. So when electron can be added easily in case of chlorine, because chlorine size is more, then more amount of energy released. So we have more electron gain enthalpy, or we can say we can have more negative electron gain enthalpy, right? More negative electron gain enthalpy. ठीक है, तो highest negative electron gain enthalpy. अच्छा, if the question comes ki more electron gain enthalpy, so it means you have to see the magnitude. Positive one more, negative one least, but the question in this we have highest negative, so highest negative is for third period element, right? So it is true. So a ka fourth, so if we match, so a is fourth, b is third, c is second, C is second and D is 1. So we have only one option with respect to that, option number D. So option number D is going to be the correct answer, right? Okay, now let's do the next question. So the electron affinity value are negative for negative. Electron affinity negative means that doesn't want to add electron. That does not want to add electron, right? So the point is electron affinity means the amount of energy released on addition of one electron in isolated gaseous atom. That is the definition for electron affinity. And the enthalpy change for the process, that is the electron gain enthalpy. So generally na, we have this thing ki suppose ki if the energy is released, yeah, electron gain enthalpy is negative for some process, then electron affinity is going to be, or electron gain enthalpy is negative for some process, then electron affinity is going to be positive. It is positive. It means if the element wants to add the electron, right, wants to add the electron, then more amount of energy is released with respect to that, right? So the question says the electron affinity value are negative for, so see, beryllium. So beryllium atomic number is 4, hydrogen, helium, lithium, beryllium 4. So when we write down the configuration, it is going to be 2s2. It is 2s2. Now this is fully filled. It is stable. It does not want to add electron, right? It does not want to add electron. If it doesn't want to add electron, then electron affinity is negative, na? Electron affinity is negative. Understood or not? It does not want to add the electron. Why? Because this is stable. Now we have nitrogen. Nitrogen atomic number is 7. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen 7. So configuration is 2s2 2p3. Again half filled, stable, so negative, negative, negative. ठीक है. अब now let's check for oxygen. So see, oxygen atomic number is 8. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. So this is what 2s2 2p4. So stepwise addition of electron happens, right? So if oxygen is in gaseous state, so it can add one electron and it forms O minus. So 2s2 2p5, right? Up now O minus है, which is 2s2 2p5. When it adds electron, na, so significant repulsion is there. Why? Because see, O negative है, O negative. If I talk about the Z effective, so Z effective is Z minus sigma. So sigma is proportional to the number of electrons. Z is same over here. So here sigma value increases, so Z effective decreases. Or we can say electron repulsion is more. So if electron repulsion is more in O minus, then it cannot accept the electron easily, right? So for this reaction, for the addition of second electron, we have to provide energy for the addition of second electron. So here electron affinity is going to be negative. O say O2 minus. So the for first step electron can be added easily, but for the next step, for the second step, in order to add second electron, that is huge. Matlab, it's a difficult process, right? Now let's talk about sodium to Na plus. So sodium atomic number is 11. So it is going to be 1s2, 2s2, 2p6 and 3s1. So outermost shell electron is 3s1. So if it gain electron, so this is going to be Na minus. So electron can be added, right? But the point is that the metals they have tendency to lose electron. They are electropositive in nature. So electrons can be added, but what happens? We have less negative electron gain enthalpy value, right? Less negative. Electron can be added because there is no such situation ki we have electron-electron repulsion or we have the stable electronic configuration. So this can happen. Okay? So this can be, we can say positive electron affinity can be there. Okay. Now next aluminium 13. So this is going to be 3s2 3p1. So again electron can be added, right? Electron can be added because we get 3s2 3p2. Obviously less amount of energy is released because aluminium is also a metal. Okay. So less negative electron gain enthalpy, but it is going to be positive. So if we talk about the negative electron affinity value, that is going to be for A, B and C. So option D is the correct answer. Okay, chaliye, let's do next question. Okay, so given below are two statements. Statement 1, the metallic radius of sodium is 1.86 angstrom and the ionic radius of Na plus is lesser than 1.86 angstrom. Is it true? Yes, it is true. Why it is true? So see, we have Na which is 3s1 and we have Na plus. I am writing complete configuration 1s2, 2s2, 2p6 and 3s1. And here Na 1s2, 2s2, 2p6. Okay? So see, Z effective is equal to Z minus sigma. So Z to same 11. And here Z effective is equal to Z minus sigma. So here Z is same. So it means effective nuclear charge is completely dependent on the sigma and sigma is directly proportional to electrons. If we have more electrons, then more electron-electron repulsion and more is the shielding constant. Okay? Now see, here we have total electrons 11 and here we have total electrons 10. So it means less electrons, less sigma, and if less sigma then Z effective is more, and if Z effective is more then the size is going to be less. Okay, so this is true. If we talk about the size of sodium is greater than the radius of Na plus. So statement 1 is correct. Now let's see the second statement. Ions are always smaller in size than the corresponding elements. So it is not true entirely. Why it is not true entirely? Because anions size are greater in comparison to the parent atom. In comparison to the parent atom. How? See, suppose Cl 17 and Cl minus and this is Cl, so 17 atomic number. So here electrons 17 and here electrons 17 plus 1 18 and here electrons 17. So here we have more electrons. More electrons means more sigma. More sigma means Z effective decreases. So if Z effective decreases then the size is more. Or we can say if chlorine accepts one electron then we have more electron-electron repulsion. And due to more electron-electron repulsion size is generally more. So statement 1 is correct but statement 2 is false. Okay. Now let's do the next question. Again given below are the two statements. So statement 1, in group 13 the stability of +1 oxidation state increases down the group. Yes, it is true. And that is due to the inert pair effect. That is due to the inert pair effects. I am going to discuss inert pair of effect. Just wait. Okay. Now statement 2, the atomic size of gallium is greater than that of aluminium. No, it's false, right? It is false. Gallium size is slightly less than aluminium. I'm not saying it's a huge difference? No, gallium size is slightly less. Why? Due to poor shielding effect of 3d electrons. Poor shielding effect of 3d electrons in gallium. So let's understand the inert pair effect, and there I'm going to discuss why gallium size is less than the aluminium. So see, we have Bagan, Aloo, Gajar in Thela. So configuration is 2s2 2p1, here 3s2 3p1, here 4s2 4p1, but before 4s we have electrons in 3d. Then 5s to 5p1, and before 5s to 5p1 electrons are in 4d. Then we have 6s to 6p1, and here electrons are in 5d10, and then 4f14. ठीक है? So अब the point is that कि see, shielding effect order is shielding effect order is shielding effect order is S greater than P, then D, then F. As electron produces more shielding or more electron repulsion in comparison to the electron in P or D or F. Okay, so the idea is that ki suppose if we remove one electron from here, so configuration becomes 4f14, 5d10 and 6s2. So penetration shielding effect order is more na, 6s is more, or we can say penetration power is greater for S than P than D and F. It means S electron wants to get closer to the nucleus in comparison to P, D and F, right? So S wants to go closer to the nucleus of an atom, due to which this type of configuration is extremely stable, and it is difficult to remove other electrons. Otherwise, if we talk about the valency of this group, this is group number 13. So valency of group 13, it can be 3, right? 3. Okay. Or if we talk about the oxidation state, it can be +3. But here down the group, +3 state stability decreases and +1 state stability increases. Why? Due to this effect, due to the penetration power, right? So here we can say that gallium +3 is greater than indium +3 and then thallium +3. And if we talk about +1 oxidation state, so thallium +1, then indium +1 and then G8 +1. ठीक है? So statement 1 is correct and statement 2 is incorrect. Also, inert pair effect is observed in group 13, 14 and 15 only, right? So stability of less oxidation state increases on moving down the group. That is the significance of the inert pair effect. I hope I am clear. Now let's do the next question. The statements that are correct about the species O2 minus F minus Na plus and Mg2 plus. So O2 minus F minus Na plus and Mg2 plus. So if we see the species, so see, oxygen atomic number is 8, fluorine 9, sodium 11 and magnesium 12. Now let's talk about the electrons. So 8 plus 2, 10. Here 9 plus 1, 10, because one negative charge, it means one extra electron is there. Here total electrons should be 11, but we have one positive charge, so 11 minus 1, 10. Total electrons are 12, but we have two positive charge, so 12 minus 2, that is equal to 10. It means these are isoelectronic species. Isoelectronic species means same number of electron. So all are isoelectronic? Yes, it is true. All are isoelectronic. Now all have the same nuclear charge? All have the same nuclear charge? No. All, देखो, see, nuclear charge is Z, and Z is equal to the number of protons. If protons are different, then nuclear charge is different. And what is effective nuclear charge? Effective nuclear charge, that is Z effective, and it is equal to total number of protons minus force of repulsion due to the electrons or inertial electrons. So it means we have to subtract the magnitude of the shielding effect. So that's how we can calculate effective nuclear charge. So that is going to be different. So this is incorrect. Now, O2 minus has the largest ionic radius. So see how to do this question. We have O2 minus, F minus, Na plus and Mg2 plus. Mg2 plus. So see Z 8, 9, 11, 12. Electrons 10, 10, 10, 10. If electrons are same, then we can say sigma is same. So it means Z effective is entirely dependent on Z. So the one which has more Z value, has more Z effective. And if that species has more Z effective, then the size is less. So atomic number of Mg2 plus is more. So it has least size and maximum size is of O2 minus. And what is the order of size? O2 minus greater, then F minus, then Na plus, and then Mg2 plus. The one which has more positive charge has least size, and the one which has more negative charge has more size. Okay? So O2 minus has the largest size. This is true. Mg2 plus has the smallest ionic radii. That is also true. So out of all the options, what are the correct? A, C, and D. So option number B is the correct. Okay, option B is correct. Now let's do the next question. The correct order of the first ionization enthalpy. See, ionization enthalpy. So this is group 13. So we have irregularities in group 13 generally with respect to atomic size, with respect to ionization enthalpy. So general irregularities with respect to size and ionization enthalpy is with group number 13. So boron, aluminium, gallium, indium, and thallium. So first ionization enthalpy, boron highest, then we have thallium, then we have gallium, then we have aluminium, and then we have indium. Okay, so thallium, gallium, aluminium. So option number B is the correct. In the above question, we have taken ionization enthalpy for gallium and aluminium almost same, because in the option we have this thing. Obviously the difference is going to be less, but gallium ka ionization enthalpy is slightly more in comparison to aluminium ionization enthalpy. Right? Ionization enthalpy. Why? Because here 4f electrons, very poor shielding effect. Due to which Z effective increases and ionization enthalpy is directly proportional to Z effective. If Z effective increases, then ionization enthalpy increases. Okay, now let's do the next question. Given below are two statements. Statement 1. The correct order of first ionization enthalpy values of lithium, sodium, fluorine, and chlorine. So let's see. Lithium is in the first group and then sodium is below that, right? So this is group 1. Then we have group 17, fluorine and chlorine, group 17. So see, ionization enthalpy increases on moving left to right and it decreases on moving down the group. So left to right ionization enthalpy increases. So highest ionization enthalpy is of fluorine. Why? Because effective nuclear charge also increases over here, right? Effective nuclear charge increases over here. The fluorine maximum. Then we have chlorine. ठीक है? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So fluorine effective nuclear charge is more in comparison to lithium, and chlorine effective nuclear charge is more in comparison to sodium, because left to right Z effective also increases. So after fluorine we have to write chlorine, then we have lithium, and then sodium. Right? Why? Sodium size is more in comparison to lithium. When we move down the group, then effective nuclear charge almost constant, right? So on moving left to right, Z effective increases. You have to apply this concept. And on moving top to bottom, size increases. So you have to apply this concept in order to find out the correct order. So here answer is fluorine, chlorine, lithium, sodium. So yes, this is true then. Then correct order of negative electron gain enthalpy value. So already discussed कि third period का more negative electron gain enthalpy in comparison to first period. So here chlorine का greater, then fluorine, then lithium and then sodium. Why? Because lithium का we can say कि भाई size is less, so more nuclear pull is there. So it can easily add electron, right? Can easily add electron due to nearer, or we can say it can easily add electron. Why? Because it is nearer to nucleus, right? Lithium atomic number 3 na, hydrogen, helium, lithium. So 1. So it is nearer to the nucleus. So it can create more nuclear pull towards the incoming electron. So electron can be added easily, right? Electron can be added easily. So chlorine, fluorine, lithium, sodium, this is also true. This is also true. So both statement 1 and 2, they are true. So option D is going to be the correct answer. Now let's do the next question. The correct order of first ionization enthalpy values of the following elements. Now here, if you see the elements, they are present in a period, right? So let's write down. So we have beryllium, boron, carbon, nitrogen, oxygen, fluorine. Okay, so we have beryllium, boron, carbon, nitrogen, oxygen, fluorine. So in this, we do not have beryllium is there, boron is there, carbon is not there. Carbon is not there. So see, if we talk about the expected order of ionization enthalpy, expected order of ionization enthalpy. So on moving left to right, Z effective increases, and if Z effective increases, then ionization enthalpy also increases, right? So fluorine highest, then oxygen, then nitrogen, then boron, then beryllium. This is the expected order. But this is not true. So what is the actual order? We have to check the electronic configuration for that. So let's check the electronic configuration for that. So this is 2s to 2p5. This is 2s to 2p4 bete. Then 2s to 2p3. Then 2s to 2p1. And here 2s2. Right, so we have to apply the concept of half-filled orbitals and fully filled orbitals. So half-filled and fully filled orbitals are more stable, right? Half-filled and fully filled orbitals are more stable. So if half-filled and fully filled orbitals are more stable, then we have to provide more energy in order to remove the electron from the isolated gaseous atom, which increases the ionization energy. So see, first is fluorine, then they nitrogen half filled. So nitrogen ionization energy is more in comparison to oxygen and carbon, right? So fluorine, then nitrogen, then oxygen, and then beryllium. So beryllium may we have to apply two concepts. First concept is of fully filled orbital and second concept is of penetration effect. So penetration effect means it is difficult to remove the electrons from s orbital in comparison to remove the electron from p orbital. So fluorine, then we have nitrogen, then we have oxygen, and then we have beryllium, and then we have boron. ठीक है. So if I want to make the comparison, तो fluorine, we have fluorine, then nitrogen, then oxygen, and then beryllium, and then boron. So fluorine is D, nitrogen is B, oxygen is A, beryllium is C, and boron is E. So the correct answer is DB, ACE. The option ACE. Option C is the correct answer. Okay, option C is the correct answer. Now, let's do the next question. Number of elements from the following that cannot form compounds with valencies which match with their respective group valencies. Respective group, matlab, which cannot match with their respective group. So, see, if we talk about boron, carbon, nitrogen, then oxygen, sulfur is over here, then we have fluorine, phosphorus is below nitrogen, aluminium is below boron, and silicon is below carbon. ठीक है, so we know that generally we know that कि second period elements ना cannot extend their valency because they do not have empty orbital. So we know that कि nitrogen has 5 lone pair ना, nitrogen 5 lone pair, 2 or 5, but it can only form 3 bonds. Why it can form 3 bonds? So see, we have 2s2 2p3. So for the covalent bond, one electron should be from nitrogen. So if nitrogen has only 3 electrons, right, 3 unpaired electrons, then it can form only 3 bonds. It can only form 3 bonds. So valency is going to be 3. It cannot be greater than 3. Similarly for oxygen, valency is 2 only, and fluorine valency is 1 only. Valency is 1 only. But if we talk about other elements, here in phosphorus valency can be extended. Valency can be extended. Just we have PCl5. So here valency of phosphorus is what? Valency of phosphorus is what? 5. Right? Valency of phosphorus is 5. So because here phosphorus 2 at 5, now 15. So valency is equal to the number of electrons in outermost shell. So here it is equal. Sulfur, we can have SF6. So it means here valency of sulfur is 6 and 286. That is the electronic configuration of sulfur. Right? So we can have this. Similarly for chlorine, chlorine ka bhi we can have different configuration, right? So if we have HClO4, ठीक है? So HClO4. So here also chlorine ka valency is going to be, matlab it can form 7 bonds like this. OH, double bond O, double bond O. So total 7 bonds, 2, 4, 5, 6, 7. So HClO4 में same. ठीक है? अब now कार्बन है तो कार्बन 14 है ना, so basically 2 और we can say 4. So here 4 ही होना चाहिए. Group number 14 है, so here 4 है, तो कार्बन can form 4 bonds, silicon also can form 4 bonds. बोरॉन है जैसे 2, 3 है, 5, atomic number is 5. So it can form 3 bonds, and as per the group valency, it should form 3 bonds. Same with aluminium, it can form 3 bonds. So number of elements from the following that cannot form compounds with valency which match with their respective group valency, that is equal to 3. So we have 3 elements for that: nitrogen, oxygen, and fluorine. Clear? Now let's do the next question. The transition metal having third ionization enthalpy, highest third ionization enthalpy. So we know that electrons are removed in stepwise manner, right? Stepwise manner. So ionization enthalpy 3 is always greater than ionization enthalpy 2 and in comparison to ionization enthalpy 1. So we have these: manganese, iron, chromium, vanadium. So देखो, scandium, titanium, vanadium 23, then chromium, then manganese 25, scandium, titanium, vanadium, chromium, manganese, and then we have iron. ठीक है, तो when we write down the configuration ना, तो see here we have 23 ना, तो you write 3d3 4s2. Here write 24 है, so here write 3d4 4s2. But we have exception in the configuration because the next configuration is more stable, so this is going to be 3d5 4s1. Manganese 25 है, so just write 3d5 4s2. Iron 26, so just write 3d6 4s2. Now if I want to remove one electron, let's remove one electron. So we get 3d3 4s1. Then remove one electron, so we get 3d3. ठीक है? So first ionization enthalpy, ionization enthalpy 1. This is ionization enthalpy 2, and if I remove one more electron, so energy associated with that is equal to ionization enthalpy 3. So this is going to be 3d2. 2. ठीक है. So chromium में first we have 3d5, then for second we have 3d4, and for third we have 3d3. So we have to find which one has highest third ionization enthalpy. So manganese first we have 4s1, or we can say 3d5 4s1. Then for second we have 3d5, and for third we have 2 electron from 3d, which is more stable configuration. More stable configuration. So here it should be highest. Now let's check for iron. So first is 3d6 4s1, second 3d6 4s0, and for third it is going to be 3d5. So highest is for manganese. So option number A is going to be the correct answer. So let's do next question. Given below are two statements. Statement 1, both metals and non-metals exist in P and D block elements. Is it true? Both metals and non-metals exist in P and D block elements. No, in D block elements we have metals. In D block elements we have metals. Non-metals lie in P block only. P block we have non-metals. We have non-metals. Right. So if I write P block elements, so P block elements group 13, 14, 15, 16, 17, 18. So here 18 to helium, neon, argon, krypton, xenon, radon, right? Below that we have organocin. Then we have fluorine, chlorine, bromine, iodine, acetone. Then we have oxygen, sulfur, selenium, tellurium, polonium. Then we have nitrogen, phosphorus, arsenic, antimony, bismuth. Then we have carbon, silicon, germanium, then lead. Group 13, boron, aluminium, gallium, indium, thallium. So in these P block elements, boron, silicon, germanium, right? Germanium, arsenic, or we can say Sb, tellurium, and polonium, right? So they could see this. This is a zigzag line now. This is a zigzag line. So these elements are generally metalloid. Polonium ka least metalloid character hai, but these are metalloids. So left hand side of metalloid we have metals, and right hand side of metalloids, we have non-metals. We have non-metals, right? So in group in P block we have non-metals only. So both metals and non-metals exist in P and D block. So this is false. This is incorrect. Non-metals have higher ionization enthalpy and higher electronegativity than metals. Yes, it is true. Why? Because non-metals lie in right hand side of the periodic table, and when we move right hand side, then what happens? Electronegativity increases due to increase in effective nuclear charge, and due to increase in effective nuclear charge, ionization enthalpy also increases. So it means statement 1 is false, but statement 2 is true. Statement 2 is true. Next question. Consider the following elements A, B, C and D. So A to B period, A to C group, B to D group, C to D period. So which of the following is a true about A dash, B dash, C dash and D dash? A dash, B dash, C dash and D dash. So order of atomic radii. Order of atomic radii. So we know that atomic radius, atomic radii, okay, left to right decreases, and on moving top to down, right, top to bottom increases. So which one has a least atomic radii? The least atomic radii is for B dash, then we have A dash, then we have D dash, and then we have C dash. So we have to apply in a period, right? Period. Because on moving down the group, number of shell also increases, thereby increasing the atomic size, right? So here B dash less because more nuclear charge or more Z effective, right? So this is true. Yes, this is true. This is true. Now order of metallic character. So if we talk about the metallic character, so metallic character means tendency to lose electrons. Tendency to lose electrons. So top to bottom metallic character increases, but on moving left to right metallic character decreases, or we can say non-metallic character increases. So we have A dash, B dash, and here we have C dash and D dash. So metallic character is highest for down the group, it increases na, so highest for C dash we can say, then it is for D dash, right? Then we have for A dash, and then we have for B dash. So this is going to be the metallic order or metallic character comparison. So C dash, D dash, A dash, B dash. Yes, it is true. It is true. So this is correct. Now size of element. If we talk about the size of element, so size of element, so this is true, na? C dash is greater. So this is false. Now let's talk about the ionic radii. So ionic radii follows the same trend as of the atomic radii. So this is also B dash, A dash, D dash, and C dash. So this is also correct. So this is also true. So it means out of all, choose a correct answer. So correct answer is going to be A, B, and D. So option D is the correct answer. Okay. Now let's do the next question. The correct sequence of electron gain enthalpy of elements listed below. Correct sequence. It means the positive electron gain enthalpy highest. Positive one. The negative one, the more negative one means lowest. Like if we have 392 and we have minus 293, obviously this is going to be lowest, na? This is going to be lowest, right? So we have to check in that way. So see, argon is what? Noble gas. So noble gas does not want to add the electron. Extremely positive and electron gain enthalpy. So it means highest is for argon. Then we have bromine, fluorine, and sulfur. So let's write down in the order. Okay. So we have fluorine, then chlorine, then bromine. We have oxygen and sulfur, right? So oxygen and sulfur. Okay. So on moving left to right, electron gain enthalpy becomes more negative. And on moving top to bottom, electron gain enthalpy becomes less negative. Less negative. Less negative means more enthalpy. So देखो sulfur है ना, sulfur. तो सबसे पहले तो we have argon because it's a noble gas. Noble gas does not want to add the electron. So it has highly positive. Highly positive. Then we have sulfur. Then we have bromine, and then we have fluorine, because fluorine ka more negative, and more negative means lowest. So if we see this, so argon, sulfur, then bromine, and then fluorine. So argon is A, sulfur is D, then bromine is B, and then fluorine is C. So we have AD, BC. So option number B is the correct answer. Understood now? More negative electron gain enthalpy means less value, less, right? And more positive means more value. So we have to understand in that way. Now let's do the next question. Given below are two statements. One is labeled as assertion A and other is labeled as reason R. Assertion A. H2T is more acidic than H2S. So what are acids? Tendency to lose H plus. Tendency to lose H plus. So H2S and H2T. Old style say chepo, right? Group 16. Okay. So on moving down the group, size increases, and hydrogen, the smallest size element, smallest size element, smallest size. So we have H2S, we have H2S, and we have H2TE. So this bond we can easily break, and if we, why we can break this bond easily? Because tellurium has more size in comparison to hydrogen. So the bond dissociation enthalpy is going to be less. So it can easily give H plus, and if it can easily give H plus, so H2T is going to be more acidic. More acidic. Why? Because the bond enthalpy of tellurium hydrogen bond is very low. So let's see assertion A, H2T is more acidic than H2S. Basically true. Bond dissociation enthalpy of H2T is lower than H2S. That is true. So we can say both A and R are true, and R is the correct explanation of the assertion. Okay. Now let's do the next question. Given below are two statements. Along the period, the chemical reactivity of the elements gradually increases from group 1 to 18. But what kind of chemical reactivity? If we talk about the chemical reactivity, now we have to understand the nature of elements. If the elements are metallic or if we have metal, right? So in order to determine the chemical reactivity, we have to find out which metal can easily give its electron. So on moving down the group, metallic character increases, or we can say chemical reactivity of group 1 or group 2 elements increases on moving down the group. But if we talk about group 17, non-metals, and non-metals, uh, they have tendency to gain electron. So tendency to gain electron decreases on moving down the group, right? Due to the basically why it decreases, because fluorine small size and highest effective nuclear charges generally. It is nearer to the nucleus, so it can create more nuclear pull towards the incoming electron. So their chemical reactivity decreases down the group. So we cannot say this, na, ki chemical generalized way we cannot say this. Ki chemical reactivity of the elements gradually increases. No, because in order to understand the chemical reactivity, we have to understand the nature of the matter. Next, the nature of oxides formed by group 1 element is basic. Yes, it's true. While that of group 17 element is acidic. It's true. This is true. Why it is true? Because in group 1 we have metals, and metals have tendency to form basic oxides. Basic oxides, na? Like if we have Na2O and if I add water in Na2O, we get NaOH. NaOH, right? Similarly, जैसे for example we have group 17 या फिर group 16, ठीक है, group 16 17, तो जैसे we have non metals, तो non metals में जैसे Ni ऑक्साइड है, जैसे फ्लोरीन है, ठीक है, ऑक्साइड ऑफ फ्लोरीन तो जनरली डेंजरस है, राइट? तो वी कैन टेक द एग्जांपल ऑफ ग्रुप group 14, like just a carbon is a non-metal, right? Carbon is a non-metal, so its famous oxide is CO2. So on addition of water in CO2 we get carbonic acid, right? So on moving left to right, acidic strength of oxides increases, and on moving top to bottom, basic strength of oxides increases. So that is true. So first statement is false and second statement is true, so this is going to be the correct answer. Okay, now let's do the next question. Okay, we have to write down the correct electronic configuration, right? Outermost. So it's very simple. The first, so you should know the atomic number of these elements. So scandium, titanium, vanadium. So vanadium is 23. Then chromium 24. Then manganese 25. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel. So nickel is 28. Okay. So how to write? Vanadium 3D 3 4s2, chromium 3D5 4s1, manganese 3D5 4s2, nickel 3D8 4s2. But we have to write down for M positive, right? Configuration for M positive, not M positive. We have to write different configuration. So vanadium plus is going to be 4s1, 3D3 4s1. So vanadium can be matched with option number 2. Then we have chromium 2 plus. So this is going to be 3D4. So chromium 2 plus can be matched with option number 3. Then we have Mn plus. So which is 3D5 4s1. So it can be matched with option number 4. Then we have Ni plus 2. Ni plus 2 is 3d8. So it can be matched with option number 1. So let's see. A option is 3, B option is 4, C option is 1, and D option is second. So we have one option with respect to that. If you know the correct answer for A, you can mark the correct answer, right? Okay, now let's do the next question. Given below are two statements. Fluorine has most negative electron gain enthalpy in its group. No. False. Why? If we have fluorine, chlorine, bromine, iodine. So fluorine has most negative electron gain enthalpy. Most negative. Then we have fluorine, then we have bromine, and then we have iodine. So this is false. Then oxygen has least negative electron gain enthalpy in its group. It is true. It is true, right? Why it is true? To see oxygen, sulfur, selenium, tellurium, right? If we talk about these elements, so highest is for tellurium, then we have selenium, then we have sulfur, and then we have oxygen. Then we have oxygen. That is the highest negative. So least is for oxygen. Why it is least for oxygen? Why it is least for oxygen? Why? Because we have to add two electrons, na? We have to add two electrons. Addition of two electrons. So देखो first तो O minus, it's fine. But when we have to add electron in O minus, na, significant electron repulsion. Too much electron repulsion is going to be there. So due to which we have to provide more energy, right? More energy. So delta Heg is going to be positive, completely positive, right? So because of the addition of two electron, oxygen has least. Yes, it is true. The answer is statement 1 is false, but statement 2 is true. So that is going to be option number C. Now let's do the next question. The element having the highest first ionization enthalpy. So in order to find out the correct ionization enthalpy, na, you have to write down the electronic configuration with respect to SPDF only. So like carbon is 6, so we have 2s2, 2p4. Aluminium 13, so we have 3s2, 3p1. Silicon 14, so we have 3s2, 3p. 1 minute. This is 1s2, 2s2, 2p2, right? 2p2. Now silicon 3s2, 3p2, and then nitrogen 7. So we have 2s2, 2p3. So highest. So see na highest. किसका? नाइट्रोजन का. Half filled orbital. Half filled. Half filled. Half filled. Maximum stability. So more amount of energy is required to remove the electron. So answer is going to be D. And if you want to write down the order, so first is for nitrogen, then it is for carbon, then it is for silicon, and then it is for aluminium, right? So that is going to be the correct order. Okay, now let's do the next question. Animal's behavior of oxygen is due to its animal's behavior. It shows different kind of behavior with respect to the elements present in the same group. Why? Because say, small size and high electronegativity. That is the reason for the animal's behavior or different behavior with respect to the other elements in the group. Small size and high electronegativity. That is the reason, and that is the memory based. That is the memory based. Okay. Now next. Given below are two statements. One is labeled as assertion A and other is labeled as reason R. The first ionization enthalpy decreases across a period. Across a period. No, it's not true. No, it's false. It's not true. It is false. Why it is false? Because on moving left to right or across a period, Z effective increases. And if Z effective increases, then ionization enthalpy also increases. So it is false. The increase in nuclear charge outweighs the shielding across the period. It is true. It is true. Because see, if we have to add electrons, na, so on moving left to right, what happens? On moving left to right, number of protons increases. Even number of electrons increases. See, let's check for period number 2. Hydrogen, helium, period number 1. Then lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So here we have 3 protons, then 4, 5, 6, 7, 8, 9. Same with the electrons, na? Same with the electrons. 3, 4, 5, 6, 7, 8, and fluorine 9 electrons. So on moving left to right, protons increases, and if protons increases, then what happens? Then what happens? Nuclear charge increases, but electron increases. So if we say electron increases, so sigma increases, na, and sigma increases, matlab it means electron repulsion increases. So but what happens here? Z effective dominates over electron repulsion. So that is true, the nuclear charge outweighs the shielding across the period. It is true. So assertion is false, but reason is true. So option A is the correct answer. Now let's do the next question. The electronegativity of group 14 elements from silicon to lead gradually decreases. So see, this is group 14, right? Group 14. So beta in group 14, chemistry sir gives Sanki problem. Okay. So see, silicon and germanium, these are metalloids. Then tin and lead, they are metals, right? Our question says the electronegativity of group 14 elements from silicon to lead gradually decreases. So what happens over here? That is false. So generally on moving top to bottom or across or down the group, electronegativity decreases. electronegativity decreases, right? But here what happens because देखो on moving down the group metallic characters increase हो रहा है ना, we have the increase in metallic character. So what happens over here? देखो कार्बन है, it's a non-metal, so more electronegativity, right? Carbon more non-metal है, it has more electronegativity. But silicon germanium metalloids है, it means ठीक ठीक electronegativity is fine. So here what happens? Generally from silicon to lead, na, from silicon to lead, electronegativity is almost same. Same हो जाता है यहाँ पे. It is almost same. That is for group 40. It is almost same. ठीक है? Because we have some metals, some metalloids, some non-metals. So electronegativity effect is not going to change. So this is false. Now next, group 14 contains non-metallic, metallic as well as metalloid elements. Why this is true, already discussed. So it means statement 1 is false and statement 2 is true. Now, next question. Given below are two statements. Statement 1, the 4F and 5F series of elements are placed separately in the periodic table to preserve the principle of classification. It is true, right? So in F block elements, right, we have group 3. F block elements, they belong to group 3. So group 3 is divided into 4F and 5F series. 4F series elements belong to period number 6, and 5F series elements belong to period number 7, right? So they are having different properties, so they place separately. Now next, S block elements can be found in pure form in nature. No, false. Because S block elements, they have one electron in outermost shell, and after the removal of one electron, they can removal of one electron, right? They can form stable electronic configuration. So they have tendency to combine with other elements in order to exist in form of compounds. So statement 1 is true, but statement 2 is false. Okay, now let's do next question. Which of the following statements are not correct? It means we have to find out the incorrect statements. So let's do it. The electron gain enthalpy of fluorine is more negative than that of chlorine. No, this is false, because chlorine electron gain enthalpy is more than fluorine. Third period. So chlorine, fluorine, then bromine, then iodine. Ionization enthalpy decreases in a group of periodic table. Decreases in a group, yes, generally it is, matlab it is going to decrease. That is the correct trend. We have some irregularities, but that is as per the general periodic property. Now next, electronegativity of an atom depends upon the atoms bonded to it. No, it depends upon the atom. It depends upon the element, not depends upon the atoms bonded to it. Okay, suppose if we have nitrogen and nitrogen is bonded to 3 hydrogen, right? Here nitrogen is bonded to 3 hydrogen, so electronegativity difference of nitrogen hydrogen is going to same. It is going to same whether we have one nitrogen hydrogen bond or we have two nitrogen hydrogen bond, it doesn't matter. Next, Al2O3 and NO are examples of amphoteric oxides. So what are amphoteric oxides? What are amphoteric oxides? Which can react with both acids, can react with both acids and bases to produce salt and water. To produce salt and water. So amphoteric metals can form amphoteric oxide. So what are amphoteric metals? Beryllium. Okay, beryllium, boron, aluminium, zinc, lead, and tin. So these are amphoteric metals and the oxides of these metals are going to be the amphoteric, right? General amphoteric. ठीक है? गैलियम का भी हो सकता है somewhat amphoteric, गैलियम, ठीक है? But generally metals, मतलब these metals are amphoteric. Okay, NO तो neutral है. NO, N2O, these are neutral oxides of nitrogen. Neutral oxides of nitrogen. If we have N2O5, right, NO2, these are acidic oxides of nitrogen. Okay, so incorrect statements A, C, and D. A, C, and D. So option B is going to be the correct answer. So now let's do the next question. For elements boron, carbon, nitrogen, lithium, beryllium, oxygen, and fluorine, the correct order of first ionization enthalpy is. So all these elements, they are present in same period. Boron, carbon, nitrogen, then lithium, beryllium. I am arranging all the elements in an order. So lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. So let's write down the electronic configuration. So lithium is 2s1, beryllium is 2s2, boron is 2s2, 2p1, carbon is 2s2, 2p2, nitrogen is 2s2, 2p3, oxygen is 2s2, 2p4, and fluorine is 2s2, 2p5. So highest is fluorine, then half-filled, more ionization enthalpy. So nitrogen, then oxygen. Then we have carbon, and here fully filled and the penetration effect. So penetration effect of S is more than P, then D, then F. So this is going to be carbon, then beryllium, then boron, and then lithium. That's it. So let's find out the correct order. So fluorine, nitrogen, oxygen, carbon, beryllium, boron, and lithium. So option number D is the correct answer. Okay, now let's do the next question. Given below are two statements. One is labeled as assertion A and the other is labeled as reason R. Assertion A: the energy required to form Mg2 plus from Mg is much higher than that required to produce Mg plus. Yes, it's true. Like Mg in gaseous state, right? If I remove one electron, let's say Mg plus, one electron is removed, right? So energy associated with this reaction is ionization enthalpy 1. Then Mg plus 1, from Mg plus 1 we can remove another electron, so this is going to be Mg2 plus, and energy associated with this reaction is equal to ionization enthalpy 2. Ionization enthalpy 2 is always greater than ionization enthalpy 1. Why? So see, here due to the presence of positive charge, electrons are less, and if electrons are less, so sigma is less, and if sigma is less, so Z effective is more. So if we have more Z effective, then energy required to remove the electron, that is going to be more, right? So that statement is true. Now Mg2 plus is small ion and carry more charge than Mg plus. This is also true. Why Mg2 plus is small ion? Because after the removal of electron in In Mg we have 12 electrons. In Mg plus we have 11 electrons. And in Mg2 plus we have 10 electrons. So obviously when you decrease the number of electrons, sigma is less and Z effective is more. And if Z effective is more, then the size is less. So both statements are true, right? Both statements are true and R is the correct explanation of it because Mg2 plus has more Z effective, right? Okay. Now let's discuss the next question. So the correct order of electronegativity for given elements. So let's try to write all the elements in the order. So we have carbon, then nitrogen. Below nitrogen we have phosphorus, then oxygen. Below that we have sulfur, and then we have fluorine, chlorine, and bromine, then iodine, and then acetylene. Right, so we have to check for carbon, phosphorus, bromine, and acetylene. Right, so we know that on moving left to right, electronegativity increases. On moving left to right, electronegativity increases. And on moving top to bottom, electronegativity decreases. So first of all, highest is going to be for bromine. Right, highest is going to be for bromine. Then we have for carbon, then we have for acetylene, and then we have for phosphorus. Then we have for phosphorus, right? So see, bromine है ना, it belongs to third period. So generally it belongs to 17th group, so more electronegative. Acetylene can have more electron, मतलब can have high electronegativity, but carbon belongs to second period, right? So if you move diagonally, na, so electronegativity is going to be almost same, or we can say it is more, right? So देखो, fluorine, chlorine, more electronegativity, most, right? If we talk about the Pauling scale, na, bromine ka around is 2.96, carbon ka is 2.5, acetylene ka it is 2.2, and phosphorus ka it is 2.19. Why we can say कि phosphorus has less electronegativity in comparison to acetylene? Because phosphorus ना half filled orbital है. So if half filled orbital has a tendency to attract the electron is also less because it has stable electronic configurations. So in that way you can memorize. So bromine highest, why 17th group. Then we have carbon because second period. On moving down the group, electronegativity decreases, right? So that's why we have to go to carbon. Now we have acetylene. After that we have phosphorus. Why phosphorus? So you can learn in that way. He half filled है, so that's why tendency to attract the electron it is going to be less. So in that way you can learn. The answer is going to be bromine, then carbon, then acetylene, and then phosphorus. Next question. Which one of the following elements will remain as liquid inside pure boiling water? Pure boiling water means boiling point is 100 degrees Celsius. 100 degrees Celsius. So see, cesium and gallium both have less melting point. Both have less melting point. Right. So question says which one of the following elements will remain as liquid inside pure boiling point? See, the point is that if the mass is more, then the boiling point is also more, right? So boiling point of gallium is extremely high. Boiling point of gallium is extremely high means it is more than water, is greater than 100 degrees Celsius. While lithium, bromine, and cesium, right? So their boiling point is less than 100 degrees Celsius, due to which at 100 degrees Celsius they remain in the steam form, right? Or they remain in the vapor form. So answer is going to be the gallium. Gallium ka melting point is low, but boiling point is high. Okay, boiling point is high. Melting point is low, but boiling point is high. That's it. Now let's do the next question. Group 13 elements react with O2 in amorphous form to form oxides. Yeah, group 13 element है ना, जैसे boron. In crystalline form it doesn't react. Only in the amorphous form boron can show any type of reaction. So group 13 elements react with O2 in amorphous form to form the oxides of type M2O3. Which among the element is the most? So see, देखो, we have boron, aluminium, gallium, indium and thallium. ठीक है? So boron we have amphoteric, right? And boron का we have amphoteric, right? Thallium का because down the group, on moving down the group, metallic character increases, right? Metallic character increases, and if metallic character increases, then basic strength increases, right? Basic strength increases. So see, we can say aluminium amphoteric, thallium basic, B2O3 acidic, and Ga2O3 also amphoteric, right? So most basic is going to be thallium oxide. That is going to be the correct answer. Now let's do the next question. The difference between electron gain enthalpies will be maximum between. So difference is highest if we have electron gain enthalpy of one element extremely positive and extremely negative. So see, if we say chlorine, so chlorine का very high, मतलब highest negative electron gain enthalpy value, and positive for noble gases. So see, neon है and argon है, तो neon में we have more size also ना, because I see we have helium, एक मिनट, just give me a moment, we have, yeah, helium, neon and argon. ठीक है? तो helium is what, 1s2, this is 2s2 2p6, and this is 3s2 3p6, right? So obviously neon outermost shell electron is more closer to the nucleus, so obviously neon may, we can say neon cannot add electron easily, right? So highest is going to be neon and chlorine. That's the option number C. Now let's do next question. The IUPAC nomenclature of an element with electronic configuration this, right? So see how to do this. Helium, neon, argon, krypton, xenon, radon. So we have to take help from the noble gases. So atomic number of helium is 2, then add 8, so this is going to be 10, then 18, sorry, then again 8, then again 8, so we get 18, then 18 we get 36, then 18 we get 54, and then 32, then we get 86. So radon is 86, right? Radon is 86, so 86 electron, and then we have 5f14 6d1 7s2. So 86, 14, 1 and 2. So total 6, 4, 10, 11, 12, 13. Then 8, 9, 10. So 103. So we have specific rule for the rules for that. So for 1 ko we can say un, 0, nil, 3, tri, and then is em. So un, nil, trium, right? Em, s suffix is added. Suffix is added. Okay. Now let's do the next question. If IUPAC name of an element is unneum, right? Unneum, yani unneum, triple one. Then the element belongs to nth group of periodic table and the value of n is. It means we have to determine the group number. So in order to find out the group number, we have to write down the electronic configuration. So obviously condensed electronic configuration and outermost shell electronic configuration we have to write. So we have to take help from the noble gas only. So see, triple one. So helium, neon, argon, krypton, xenon and radon. So radon is 86. We have just solved the question. So first the radon, 86. अब see, helium belongs to first period. Okay, neon belongs to second, argon belongs to third, krypton belongs to fourth, belongs to fifth, and radon belongs to sixth. It means triple one element is going to belong to seventh period. So if it belongs to seventh period, then the valence shell triple one must belong to seventh period. Must belong to seventh period. Seventh period. So valence shell is going to be 7s 7p. Then we have shell, which is placed behind, or which is behind valence shell, right? That is called penultimate shell. So that is going to be 6D. And anti-penultimate shell means the shell which is before penultimate. So that is going to be 5F. So generally valence shell is represented by NS and NP, where N is equal to the period number, right? Then we have N minus 1D, and then we have N minus 2F. Now the next thing is to fill the electrons. So for fill the electrons, we have to find out the energy, and energy we are going to find in terms of N plus L. So L का value for S के लिए 0, P के लिए 1, D के लिए 2 and F के लिए 3. We know this from the atomic structure. So let's find out the energy. So 7 plus 0, 7, 7 plus 1, 8, and this is 6 plus 2, 8, and then 5 plus 3, 8. So it means first electron goes to 7s because it has lowest energy, to 7s2. Now 5F, 6D and 7P, they all have equal energy, right? So now the electron goes to that orbital which has lowest value of N. So it means now electron goes to 5F, 5F 14. So 86 plus 14, 100, 102. Okay, total 102. We have to fill 111. So 111 minus 102. So 69. So here last electron enters into D subshell. So it's a D block. It's a D block element, and we know that D block elements they are from group 3 to group 12. Now period is 7. Period is 7. In order to determine the group for D block, we have to add electrons for N minus 1 D electrons plus NS electrons. So you have to add these electrons. So N minus 1 D electrons means total electrons 9 and 7 is 2. So it means 9 plus 2, total 11. So group number is 11. Answer is 11. Okay. So that's it. Now let's do the next question. Total number of acidic oxides among the following. So see, we know that NO2 is acidic because if you add water in NO2, so we get 2 acid, HNO3 and HNO2. N2O is neutral. ठीक है? Cl2O7 acidic. SO2 acidic. We get sulfurous acid. CO neutral. CaO metal oxide basic. Na2O metal oxide basic. NO nitric oxide neutral. Then we have N2O3. N2O3 that is also going to be acidic oxide. That is also going to be acidic oxide. NO and N2O5, matlab NO and N2O, they are neutral oxide. So total number of acidic oxides 1, 2, 3 and 4. So total oxides 4. So answer is 4. Clear? Okay. Now let's do the next question. Number of amphoteric compounds from the following. So I have already discussed, right? So beryllium is amphoteric metal. Beryllium is amphoteric. Barium and strontium, they are basically, they form basic oxides because down the group metallic character increases, right? So beryllium is amphoteric. So number of amphoteric compounds, they are going to be beryllium oxide and beryllium hydroxide. Beryllium hydroxide. It means beryllium oxide can react with HCl to form salt, BeCl2 plus water, and BeO can react with NaOH also, to form sodium berylliate, Na2BeO2 plus water, right? So that's the behavior of amphoteric compounds. Same with beryllium hydroxide. Same with beryllium hydroxide. Okay, so that's it for the periodic classification of elements. We have discussed almost every type of question, but the thing is, the more you practice, the more you get confidence in the periodic classification of elements. It's really a very simple chapter. Now try to do other previous year questions, right? You have to take one reference book and just try to solve as many questions as you can. Okay, that's it for today. So see you in the next video, and in the next video we are going to discuss some questions of the chemical bonding, but just see it. Okay, so bye, take care, see you in the next class or see you in the next video. Bye.